Something really big is happening right now in the world of AI. We're seeing a huge shift, a move away from just getting AI to generate perfect sentences and towards something way, way deeper, a genuine understanding of reality. This is all about creating an intelligence that doesn't need to describe the world in order to understand it. It's an AI that can grasp the meaning of what it sees directly, completely bypassing the slow, often messy process of translating what's happening into words. This idea really redefines what it means for a machine to think. Now, to really get why this is such a huge deal, we first have to pull back the curtain on a hidden flaw in how most of our advanced AI models work today. And it all boils down to one little thing: tokens. You see, the way it works right now is this. When a vision language model sees an image and you ask it something, it answers by predicting the next word, or token. Then, based on that word, it predicts the next one, and so on and so on. It's this one after the other process that's at the heart of nearly every major multimodal AI out there. And right here, the problem just becomes crystal clear. For you and me, these two sentences mean the exact same thing. But for an AI that thinks in words, these are just two totally different strings of symbols. They have almost zero overlap. So the model has to learn that both of them are correct answers, which means it's spending its time memorizing language variations instead of actually getting the core concept. And this leads to a couple of massive problems. First, a huge amount of training time and energy is just wasted on modeling the surface of language, things like phrasing and word choice, instead of the real meaning underneath. And second, because the answer comes out word by word, the model's full understanding only shows up right at the very end. That adds a delay, a latency, which makes it totally impractical for real-time stuff like robotics or smart glasses. Okay, so that's the problem, and this is where a completely new approach comes in, one designed to solve these exact issues. It basically rethinks the AI's entire goal from the ground up. It shifts from generating words to understanding meaning. This is VJPUD. Instead of living in the world of words, it operates in this abstract space of meaning, which is represented by these mathematical vectors called embeddings. You can think of them like coordinates on a giant map of concepts. VJPUD learns to predict the meaning of an answer directly from what it sees. The way it learns to do this is pretty clever. The entire architecture is built specifically to create a conceptual map of the world, not just a dictionary of phrases. Let's just walk through how it works. It's got four main parts. First up, the visual encoder. This is what sees the world, turning video frames into those meaning vectors. Second, you have the predictor. This is really the brains of the whole operation. It takes the visual info and a question, and then it predicts the meaning of the answer. Now, during training, a YAI encoder takes the correct text answer and turns it into a target meaning. And last, there's the YAI decoder, which is only used at the very end to turn that meaning back into text for us humans to read. It is completely separate from the actual learning process. So the whole training game is just incredibly direct. The model's entire job is to close the gap between the meaning it predicts and the target meaning from the correct answer. That's it. It never generates a single word during training. It just learns to line up its internal understanding of the world with the concept of the right answer. And the outcome of this is pretty profound. Because the model isn't busy learning how to write sentences, it's forced to build this structured semantic space. In this meaning map, answers that mean similar things, like the room gets darker and the light turns off, they just naturally end up close together. It's learning the concept, not just the words we use to describe it. All right, so that's the theory. It sounds great, but does it actually work in practice? Well, this is where the real advantages of this whole approach become impossible to ignore. In a straight-up, head-to-head comparison, a VJPUD model with half the trainable parameters learned way more effectively than a traditional token-based model. I mean, after millions of training samples, its score on video captioning was more than double its competitor. This isn't just a little better, that is a massive leap in how efficiently it learns. And that efficiency carries right over into real-world use. When you're analyzing a long video, VJPUD can do something called selective decoding. So instead of constantly spitting out text, it only generates a description when the meaning of what it's seeing actually changes. This leads to a nearly threefold reduction in the most computationally expensive part of the process. That's a total game changer for any real-time application. And what's more, this one single architecture is incredibly versatile. It can classify objects, find videos based on text, answer questions, And it does all of this without needing specialized add-ons for each task. It handles everything just by comparing meanings in its embedding space, and on average, it even outperforms models that were built for one specific job. But here's the most powerful piece of the puzzle, the part that really shows what this is all about. It's the model's ability to go beyond just describing things and start showing a real grasp of cause and effect. On a benchmark specifically designed to test an AI's understanding of physical causality, VJPUD set a new state-of-the-art. It outperformed even the largest frontier models out there, like GPT-4o. This is such a critical result. It suggests that by reasoning directly about meaning, it can get a more robust, a more grounded understanding of the world than models that have to first describe the world in words and then reason over that text. So ultimately, when we're talking about AI that needs to see and interact with the physical world, the future isn't about writing more eloquent prose. The true leap forward is in building systems that can understand the world on its own terms. This shift from language to meaning is a fundamental change, and it's going to redefine what AI is truly capable of.